All right, John Wager, would you like to come forward? Today he's going to be talking about Sir Harry Ricardo, who had a lot to do with engines and diesels and aero engines. John, over to you.
Thank you, Brian. Earlier, we've spoken about folk who were well known not only to folk with aircraft in mind, but also the general public. They were well known, like Henry Royce and Frank Whittle, public figures. Harry Ricardo is not widely known, which is a bit of a shame, because really he had devoted the whole of his life, and it was quite a long life, into the development of aircraft engines, vehicle engines, and internal combustion engines in general. He contributed himself to that somewhat, because he was always in the background. He was never an employee. He was always a contractual consultant to many companies. That seemed to be his role, the knowledgeable man in the background. I'm basing the bulk of my address on this book, which was written by John Reynolds, a well-known, well-respected historian of internal combustion engines. This is what he looks like for those who didn't know him. And as I said, he had a profound influence on the development of the I.C.Engine. He set up a workshop in 1917 to study what we know as knock, or premature detonation. 1917, quite an early experiment. And he had pioneering work on automobile and aircraft engines. But as I said, he was always an independent consultant. He was not connected with any specific make of car or maker of aeroplanes. But he worked behind the scenes for Rolls-Royce, for Bentley, for Bristol, Napier, Citroen and Fiat. And he had a vital role in 2 world wars. And we all think of him when we pull in these days to a fuel pump, because the concept of octane ratings was born by Ricardo working with Shell. He also pioneered the high-speed diesel engines for common road use. He produced the world's first diesel passenger car with Citroen in 1934. He was a noted writer and educator. His company, Ricardo Consulting Engineers, became the foremost internal combustion engine research establishment in Britain. This is where he was born, in Bedford Square, in 1885, 15 years before the turn of the century. And that house to this day carries the blue plaque confirming his birthplace. He was born before the ownership of cars, motor cars, was widespread. The early exponents of the car were self-taught mechanics. Henry Ford, Louis Renault, William Morris, Henry Royce. But Ricardo came from a professional family with no previous involvement in mechanical design. His father, Halsey Ricardo, was an architect. There he is, looking very architectural. His maternal grandfather was Sir Alexander Randall. He was a noted English civil engineer whose company also built the Indian railway system. Doesn't he look like a fellow who could build a railway system in any country? His uncle Percy moved to Australia, and in the 3 years, 1902 to 1905, was here in Western Australia. He was the military commandant of the state. We didn't know that. Nobody knew that. So we learn something every day. Big tick, he was in WA. And his son, Ralph, later became Harry's friend and business partner. The world closes on itself. At age 10, Harry was sent to Rottingdean School. What a name. Rottingdean School. There he is, looking a very bright little pupil. But Rottingdean derided Harry's mechanical interests, and they imposed a very strict discipline on the lad. But at home, his father encouraged him, bought him a small lathe, and encouraged him to build a small working steam engine. Through a family friend, Harry met Rudyard Kipling, which would be an interesting man to me. And Rudyard Kipling encouraged his mechanical interests. In 1898, Harry went to rugby school. He shared a study with Arthur Ransom. Who's read Swallows and Amazons? Oh, well, did you enjoy it as much as I did? Arthur Ransom is a fascinating fellow. Swallows and Amazons is a book about youngsters who loved sailing. They sailed a boat that looked like a bit like a clinker-built cadet dinghy, and the youngsters went camping on an island in the Lake District. But it was written in such a way that anyone who likes flying or sailing, which is really two-dimensional flying, would love that book. And I'm sure that influenced Harry as well. While at rugby, Harry formed a friendship with his cousin, as I mentioned, Ralph Ricardo. They designed and built many miniature steam engines, and they did it in a kit form, selling them for 20 shillings, which at that time was quite a tidy sum. And this was before his 20s. In his final year at rugby, Harry prepared and he read a paper to the Natural History Society on a wide range of steam engines and I.C. engines. This caught the attention of Sir Dougal Clark, who was himself a pioneer in I.C. engine design, and he became Harry's mentor and his friend. There he is, looking suitably academic. Harry pursued his concept of a stratified charge in an I.C. engine, that is, matching the strength of the charge with the load imposed on the engine. Using the stratified charge, he built a petrol engine to drive a water pump at his father's house. There's his creation. In 1903, Harry went to Cambridge University. Also in 1983, the Wright brothers took the I.C. engine into the air, and Harry from there followed aircraft development with interest. He was born in the year that saw the creation of the car. He learnt to drive cars, similar to his father-in-laws, Panhard and Levasseur. I'm sure this photograph was taken with a car carefully parked, because even at the sedate rate at which cars proceeded in that period, his top hat would have blown off. At Cambridge, he joined the University Automobile Club. He had access to University Mechanical Workshop. He designed and built 900cc single-cylinder four-stroke motorcycle. He attracted the attention of Professor Bertram Hopkinson. He studied efficient combustion, and he won a limited fuel endurance trial. there's his mentor. Professor Hopkinson invited Harry to join his IC research team, and Harry worked for 3 years, more as a partner than an assistant. His main study was in, as we earlier mentioned, the nature of knock. In 1906, Ralph Ricardo, his cousin, proposed that he and Harry and 2 undergraduate friends form a company to manufacture 2-cylinder and 4-cylinder versions of a 2-stroke engine for light cars, which they would also design. And this became known as their Dolphin Venture. Ralph was the director, and as I mentioned, Harry in the background was consulting engineer. Premises were leased at Shoreham by Sea. That's what it looked like. There's a cadet dinghy in the foreground. And remembering that they were barely in their 20s, this was their company's workshop. And this was the machine. For someone who's aged 20 at that year to design this outfit was quite an achievement. You can't read the text there very well, but the point they're making there is that instead of the compression in this 2-stroke engine being through the crankcase, the compression was by a separate compressing cylinder which fed the combustion cylinder. Here it is. There's the compression cylinder and there's the working cylinder. But after some years and declining sales, the Dolphin project was discontinued. In 1911, Harry married Beatrice Hale, the daughter of his family doctor. Their marriage lasted for over 60 years. Very good achievement. They rented a house at Walton on the river, and there she is, looking happily nautical. I don't know what the crank handle in the foreground is. It might have been a version of motive power to get a propeller going. But she seemed very happy. For some years, 1907 to 1913, Harry joined his grandfather's civil engineering company, concerning himself with mechanical equipment involved in the construction world. He pursued his idea of establishing a research laboratory to assist all British I.C.Engine builders. At his home in Walton, he designed a supercharged 12-cylinder V-configuration 4-stroke engine of 300 horsepower. Now you might have noticed that I've put that in italics and I've used a slightly bigger font style because I think that's very significant. This preceded what became the Merlin. And I'm not sure whether Henry Royce knew about this beforehand or not, but just bear that one in mind. Because Harry Ricardo had this creation in mind as being an aircraft engine. In 1914, Harry was sent on a visit to civil and mechanical engineers in America and Holland and Sweden and Italy and Germany. On August the 1st, 1914, he was in Aachen and was advised it would be prudent if he could return immediately to England. In England, Harry was classified as being in a reserved occupation. He was a very valuable citizen. At his workshop, he designed a 6-cylinder, 230 horsepower Aero Engine, incorporating a supercharger of his own design. This was his workshop, very modest, and this was the engine. You can possibly see there 230 bhp. That doesn't stand for, although it could have, brake horsepower. It stood for the makers, Beardmore, Halford and Pullinger. Ricardo also designed a 150 horsepower 6-cylinder tank engine that were built by Gardner. Over 8,000. Imagine 8,000 tank engines. Frightening. Between 1917 and 1918. I don't know what the dog thinks of it all. In 1915, a private company, Engine Patents Limited, was registered. Harry was the technical director and the chairman was Campbell Swinton. In 1917, the company set up a research laboratory at Shoreham, which was known as the Bridge Works. And that's when cooperation started with the Shell Company on the development of appropriate fuels. That's Harry on the left. And there's the Bridge Works. And this is the most crucial of his experiments, the variable compression ratio experimental engine. This gentleman here, turning the handwheel, is actually setting different compression ratios by arranging that the operating engine could have its cylinder head lowered towards the crankshaft or not, while the engine was still operating. The power was measured with this dynamo, which was fitted with or mounted on ball bearings, but it was held in a certain position by this frame and the reaction on a spring balance. So this gentleman is very earnestly looking at this spring balance while he's adjusting the frame voltage on the dynamo. So they could measure the performance of the engine, the compression ratio, and this guy is keeping an eye on the temperature. It was quite an earth-shattering concept, and as I said earlier, one that we use every day when we pull into the fuel pump. What octane do we want? This was the machine shop. Remember, they were in their early 20s. It's quite an achievement. But Ricardo's high octane fuel was used for many aircraft. This is Alcock and Brown's crossing the Atlantic Vimy in 1919. Since 1916, Ricardo had been associated with Rolls-Royce and had a great respect for Henry Royce. The two met at the Bridge Works in 1920. Remember, this is some years after Ricardo had designed the 12-cylinder V engine with aircraft applications in mind. But they developed a strong friendship, a reminder of Henry Royce. Ricardo's colleague, Frank Halford, had success on the racetrack with the Triumph Ricardo motorcycle, and also Ricardo engine Vauxhall racing cars with those fluted radiator covers on the Isle of Man. And in 1937, the largest engine assembled and tested at the Bridge Works, a two-stroke diesel for submarines. This was their family home at Lansing, where they lived from 1919 to 1933. Ricardo was invited to design, when he was about 40, a 12 horsepower car for the French Le Zèbre company. Le Zèbre means a zebra. I don't know why you'd call a car a zebra, but it was called a zebra. he had full responsibility not only for the engine but for the chassis and the bodywork. And there it is, quite a respectable looking machine for the age. He was a yachtsman, which appealed to me. He sailed his Pearl for 15 years. It's quite a sizable vessel. He had contacts in America, in addition to Chrysler and Caterpillar and the Waukesha Engine Company. He had the Harley Davidson on his books. This was a Harley Davidson advertisement at the time, and you possibly can't read the fine print, but the key bit that I'm pointing to is this bit. It had a new Ricardo head motor. This is a 3-cylinder version of the Brotherhood diesel for electric power generation, which was widely accepted. Ricardo in 1929 solved the problem of excessive diesel fumes for transport buses. He used what was called the Ricardo Comet combustion chamber. It had a spherical chamber and it was attached to the cylinder by a tangential passage. There's one. And there's a London bus in 1937 with an AEC Ricardo diesel engine. In the 1930s, Imperial Airways had 4 Bristol Jupiter engines. Ricardo seemed to favour radial aircraft engines for some reason. Ricardo formed a strong bond with André Citroen, and he developed the high-speed diesel for passenger cars. There it is, and there is André Citroen. You remember that Citroen was a successful mechanical engineer long before motorcars were developed and built. Citroen, was mechanical engineer for steel rolling mills, and he solved a number of problems in energy transmission in rolling mills by double helical gears. So when he started building motor cars, he had this symbol that you'll see on Citroen cars even today of his double helical gears. In 1938, he engined a Grand Prix car. There it is, looking very streamlined. This is a cross-section of the engine. It's interesting. There's the engine, and this is the supercharger. In 1936, Germany showed off their newly created military and industrial might, which for aircraft was greater than that of Britain and France and the US combined. It's a bit frightening thought. On an engineering visit to Germany in 1938, Ricardo was presented a certificate of membership of the German Academy of Aeronautical Research by no less than Hermann Göring. Here it is. Die Deutsche Akademie der Luftfahrtforschung. And there's his name, Harry Ricardo, and down the bottom is the General Marshal Göring. I'm sure Harry noted with avid interest all that he saw in Germany, because he was serving as an independent member of the UK Aeronautical Research Committee. Very timely, very useful. As I mentioned earlier, he'd undertaken work on air-cooled radial engines, especially on the design of crankshafts with the multiple connecting rod configurations. And many were long-lived, like the Fairy Swordfish or the Bristol Pegasus engine. And also the Imperial Airways, the short Empire flying boat. And also with the Napier Company, the Napier Sabre. What a fascinating engine. It was two 12-cylinder opposed cylinders on one particular crankshaft above a bank of another 12 opposed cylinder engines on a separate crankshaft with a common gearing to an output shaft. So instead of the 300 and 400 and 500 horsepower of his earlier engines, he had 2,400 horsepower for the Napier Sabre. It's quite an achievement. Imagine pushing the throttle forward on that lot. And this is, and I've not seen this photograph before, in 1944, Rolls-Royce built the I.C.Engine, which was actually based on Ricardo's, it says here 1937 research engine, but it's the one that he had designed and had in mind for aircraft in 1913. In the 1950s, many British-built diesel-engined vehicles all used Ricardo's Comet combustion chamber to great effect. And there was the interesting but short-lived British Railways diesel mechanical direct drive. This was a fascinating concept. It was one of a number of concepts that included the Deltic that I've spoken about earlier, the multi-engine cylinder configuration. Both this one and the Deltic were designed as interim motive powers for rail before electrification could become fully commissioned. So this one, although very interesting, was only short-lived because electric rail power was becoming fully accepted. So here they are, in 1962, the board of directors of Ricardo Consulting Engineers. In his lifetime, which was quite a significant lifetime, he lived to 89, he set up and made good use of Ricardo Consulting Engineers. He obviously had a profound influence on a whole range of internal combustion engines. In 1929, he was elected a member of the Royal Society, a fellow. In 1944-45, he was president of the Institution of Mechanical Engineers. He became Sir Harry Ricardo in 1948, and he died age 89 in 1974. I've enjoyed meeting him. It's been great learning about him. I hope you've enjoyed it too. Thank you.